All right, good morning, good morning, good morning. This is your measurement, conversion, and geometry study guide. You are here with my first class. Everybody say whoop, whoop. There we go. All right. We are going to be doing this together. We're going to do 12 questions. We're going to pause it and dance. And then we'll do the last 13 questions and pause it and dance. This is all about measurement conversions and geometry, and then there's a bunch of review questions thrown in there. So here we go. Which statement best describes why a rhombus is a type of parallelogram? Well, first off, draw both. Draw a rhombus. Janie, what does a rhombus have to have? Very good. It's got to have parallel sides. This side and this side are parallel. And this side and this side are parallel. Sydney, what else does a rhombus have to have? Anybody remember? What's it got to have? Not 4 right angles. It's got to have, Janie, 4 equal sides. This side and this side and this side and this side are all equal. All right, now let's draw a parallelogram. Parallelogram goes here. It's long, it's this, and it's like this. What is the only rule for a parallelogram besides having 4 sides? What is the rule for a parallelogram? What's it got to have? Matthew? Good. It's got to have 2 sets of parallel sides. So that side, those 2 sides, and these 2 sides are parallel. So do y'all see something that's the same on both? Yes, they both have to have 2 pairs of parallel sides. And you know that because a rhombus, you can write that down, a rhombus is a parallelogram. Remember, his daddy is Graham. Parallelogram. His daddy is Graham, so he's a parallelogram. He's part of the parallelogram family. Him, his brother Rectangle, and their dog Square. They're all parallelograms. Got it? All right. Here we go. Kristen drank 7 cups of coffee on Monday morning. I'm going to underline that. On Friday morning. She drank 2 cups on Saturday and 3 cups on Sunday. This girl has really got a caffeine problem. If each scoop of coffee makes 1/4 a cup of coffee, how many scoops of coffee did she use over those 3 days? Okay, so what you got to do is you got to add together your cups of coffee. So add 7 plus 3 plus 3, or 7 plus 3 plus 2, sorry. You have to add those together, and then you have to divide that into fourths to figure out how many scoops it's going to, how many scoops of coffee it's going to take over all those days. Get it? All right, so here we go. What's 7 plus 2 plus 3, Wyatt? This is 12. And I've got 12 divided into fourths. Sam, how do I divide with a fraction? You are a genius, Sam. He says keep, change, flip. So I'm going to keep the first fraction. I'm going to change that to multiplication, and I'm going to flip that over to 4/1. I'm going to get 12 times 4 is 48 over 1 is, he can make, it's going to take 48 scoops of coffee to make those 12 cups of coffee. That's a lot, 48 scoops. My goodness, hopefully the scooper is small. Next one, we're going to draw the quadrilateral hierarchy. Now, y'all just did this. Those of you at home, we just did this on in our notebooks. It looks like this. Let me slide out. It looks like this. And I'm going to have them do a quick and dirty version on their study guide. So we're just going to write the initials. 4 at the top, you're going to write Q for quadrilaterals. All quadrilaterals have 4 sides. We're going to go super quick. 2 brothers. What are the brothers' names? Give me one of them, Liam. What's the weird uncle? All right, trapezius here, trapezoid. What's the other brother's name? Wyatt, I mean, not Wyatt, Evan. Good, Graham. So I'm gonna write, let's call him P. Graham. Old P. Graham. We call my son P. Diddy, so we can call him P. Graham. All right. Graham has 2 sons. What are their names, Talia? Good. We got Rec, we got Rhombus, and we got old Rec. And then they have a dog. What's the dog's name? Tinley? Square. Cool. Remember that it is always the things above it. And it is never the thing below it. Not never, sometimes. Sorry, sometimes. Sometimes. Why did I say that? Sometimes the things below it. All right. So which one can technically be called a rhombus, a rectangle, square, a gram, and a quadrilateral? Which one is all the things above it? Square. Good. The square. Let's write that down. The square is it's so many things. It's a rhombus. And it's a rhombus because it has 4 equal sides. Square is a rectangle because it has 4 right angles. Square is a p-gram because it has 2 sets of parallel sides. And a square is a quadrilateral because it has 4 sides. But is a square a trapezoid? No, there's no line connecting square to old trapeze. Remember trapeze? Weird uncle lives in his basement all by himself, watching anime, making his mama cook his dinner every night. He's a little strange. Okay. He never wanted to get married. He just likes to play video games. Yes. What is his mom's name? I don't know, but her last name is Quadrilateral. Maybe it's the Quadrilateral. All right, here we go. All right, next. All right, so this is the quadrilateral hierarchy. The one that you guys are going to have trouble remembering is that this, draw a rhombus, that a rhombus has 4 equal sides and a rectangle has 4 right angles. That's going to be the one that gives y'all the most trouble. You're going to mix those up. All righty. Next one. Victoria's marker measures 6 7/100 millimeters. Adrian's marker weighs 2 3/10 millimeters. How much do they measure together in centimeters? All right, so first you got to add them. So add 6.7, 6 7/10, add that to 2 and 3 to figure out how many millimeters we have in all. So I've got 7 plus 3 is 10. I've got 0, carry the 1. 1 plus 6 plus 2 is 9. So I need to turn 9 mm's into centimeters. You have to write that down. All right, now here we go. Sydney, what's bigger, a millimeter or a centimeter? Very good. Write big over here, small over here. Sydney, if I'm going fly to horse, what do I do? Small to big. I'm going to divide. Divide by what, Sydney? How many millimeters are in a centimeter? 10. So you're going to do 9 divided by 10. Y'all think y'all can write that as Dr. Phil? 9 divided by 10 is 9/10, which is 9/10. You could also just move your decimal 1 place to the left because King Henry died, unit, drinking chocolate milk. So if I'm going from millimeter to centimeter, I can move my decimal one place. So if I start with 9 and my decimal's here, I can just move it over. Bing, move it to there. And now it is 9/10. You can do the decimal sliding, or you can Dr. Phil, or you can just take your stinking calculator and type it in. Do 9 divided by 10. Everybody take your calculator, divide 9 by 10. Everybody take out a calculator, divide 9 by 10. Go, go, go. I'm getting my calculator. I got time going back here. 1. So if I open up my calculator, and I have it right here in front of me, and Miss Ross gave me the conversion, and I know I'm going small to big. So all I got to do is come in here and go, watch this, kids, this is fun. 9 divided by 10 equals 9/10. I know. So you're going to have a calculator. Even if you don't, you know how to Dr. Phil on this. All right, next one. Miss Ross wants to make goodie bags for her students. She has 347 pieces of candy and she puts 9 pieces into each bag. How many complete, highlight that or underline it. How many complete goodie bags can she make? So let's divide. I've got 347 and I'm going to divide it by 9. All right. Layla, can 9 divide into 3? No, put an X over top of it. Layla, how many 9s are in 34? There are, what'd she say, 3? Yes, 3. 3 times 9 is 27. When you subtract, you get 7. Then bring down the 7. Carson, how many 9s are in 77? There are 8. What's 8 times 9, Carson? 72. When I subtract, I get 5 left over. Hey, Sydney, let me ask you a question. Do you want a goodie bag that has 5 in it when everybody else is getting one with 9 in it? No, forget about that guy. So she can make 38 complete ones. Nobody wants one. Complete means it'll have 9 in each. Complete means 9 in each. Nobody wants that last goodie bag that will have 5 in it. That's some ridiculousness. Colt would say, wait a minute, it's my birthday. What about me? Oh, sorry. All right, next one. And maybe we'll dance after every 6. Nah, that's too much dancing. All right, here we go. Dora worked on schoolwork for 3/4 of an hour on Tuesday. Of that time, 5/6 of it was spent on work for AIG. So she had 3/4 of an hour working on homework, and 5/6 of that time was spent working on AIG. How do I find a fraction of a fraction, Talia? Very good. I'm going to multiply. So I'm just going to go like that. Cross off of, put multiply. 5 times 3 is 15. 6 times 4 is 24. Now, Wyatt, is that improper? No, but I can divide the top and the bottom by what number to simplify it? 3 is correct. 15 divided by 3 is 5. 24 divided by 3 is 8. Your answer is 5/8. Now, so be it. Is there anything on here that's been blowing your mind so far? No? Tinley says no. Anybody else feeling differently? Jaden, what about you? You're usually a pretty good barometer. He says he's not confused. Jamie, you confused? Said you confused? Evan, you confused on anything? All right, let's flip. Next page. Here we go. Oh, no. My thing bled through. All right, let's go to the back here and we will keep going. We got here. We're going to dance after 12. All right. A theater has 5,608 seats. If there are 8 seats in each row, how many rows are there? So you have to divide 5,608. And guys, can I do it down here? Because I don't have enough room. I'm going to do 5,608. And I'm going to divide it into 8 seats in each row. All right, you're up, Tinley. Tinley, how many 8s are in 5? How many 8s are in 56? What's 7 times 8? What's 56 minus 6? Sorry, what's 56 minus 56? Bring down the 0. Now, if you bring down a 0 from upstairs, you better play with it. Evan, how many 8s are in 0? Put that answer up top. Evan, what's 0 times 8? 0 minus 0. Now bring down the 8. Evan, how many 8s are in 8? 1 times 8. 8 minus 8. My answer is 701 rows. That's old school math right there. Y'all been working on that since 4th grade. All right, here we go. So we are up here for number 8. I want you to write this down because they will put it on your test. It'll tell you that 1 kilometer equals 1,000 meters. They will have that on your test. They will have that on the EOG. You don't have to know the conversion. All right, so Jeremiah has to run for a total of 7 kilometers to prepare for a race. So I want you to underline kilometers. And it says he's run 5,673 meters. Okay, so are kilometers and meters the same right now? They're different units, right? So what you need to do is you need to turn these 7 kilometers into meters so you can see how many more meters he has left to run. Because he wants to know how many more meters he has to run. So you're turning 7 kilometers into meters. So Hadassah, what's bigger, a kilometer or a meter? Very good. This is the big, this is the small. So Hadassah, if I'm going from something big to small, horse to fly, I multiply. Good. So 7 times what? Well, Hadassah, how many meters are in a kilometer? 1,000. So Hadassah, 7 kilometers is how many meters? You're a genius, Hadassah. So he needs to run 7,000. He's only run that much. So we need to subtract. Do 7,000 minus 5,673. And I'm going to pick on you, Levante. All right, Levante, can I subtract 3 from 0? No, borrow all the way over to a 7. 7 turns into, good. This 0 turns into a 9. This 0 turns into a 9. And the last 0 turns into a 10. The last one turns into a 10. 10 minus 3 is 7. 9 minus 7 is 2. 9 minus 6 is 3. 6 minus 5 is 1. So he's got 1,327 more meters to run. That one was a 2-stepper. You have to turn the kilometers into meters and then subtract. But they're going to give you the conversion, and you're also going to know big to small, small to big. You know that part. All right, here we go. Bryce had 6 cups of flour. Oh, sorry. Thank you. Thank you very much. Bryce had 5 cups of flour. If he uses an 1/8 cup of flour per pan of brownies, how many pounds of brownies can he make? Carson, how do you think I should set this up? I got 5 and I'm scooping out an 1/8 cup every single pan. So I start with 5, and every time I make a cup of flour, I make a pan of brownies, I'm taking out an 8. So I'm dividing it into 8 cups. Do you see what I'm saying? And that'll let me know how many pans of brownies I can make. So Jaden, how do I solve this? Keep, change, flip. Put your 1 under there. So I'm going to keep, I'm going to change, and I'm going to flip. And that means I can make 40 cups of 40 pans of brownies, which would make sense because for every cup I can make 8 pans, right? An eighth, 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 an eighth. Huh. Which name can be used to describe all of the figures shown below? I'm going to draw a bunch of figures. You ready? Draw this. Make the 4 sides equal. Like that. Draw this. Give it 4 right angles. This side and this side are equal, and this side and this side are equal. Give me another one. All right. So what is it that all 4 of them have? They're all quadrilaterals. We know that. They're all quadrilaterals because they've all got 4 sides. They're all parallelograms because their opposite sides are parallel. What is the other thing that all of them can be called, Levante? They are all squares. Because, nope, they're not all squares, are they? No, to be a square, you've got to have 4 right angles and 4 equal sides. What are they? They're all rectangles. They are all rectangles. Because they all have 4 equal sides. All right. Olivia spends 3½ hours riding her bike each week. Langley rides his bike for 1/4 of that time. Liam, how do I find 1/4 of 3½? Good. So write 1/4 of 3½ So you could see it written that way, or you could see it written this. 1/4 times, you could see it as 7/2, right? Because that would be how you multiply it out. One more, and then we're going to dance. You ready? Over here, draw a square. Big square. Big square. Draw 4 lines going up and down. 1, 2, 3, 4. Draw 4 lines going left and right. You're trying to make a grid. 1, 2, 3, 4. Just like that. Then I want you to number, label the origin. Then this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. I'm going to pause that there for just a second. Let y'all catch up. All right, here we go. So the coordinates of point K are 3, 5. So we are going to run, we are going to jump, and we are going to put 3, 5 right here. And we're going to label that thing K. Label that K. All right. So let's say that we increase the y coordinate by 3. So right now the coordinates are 3, 5. This is the x, this is the y. So they're saying, what if you take 5, add 3 to it? My new coordinate is going to be 3, 8, correct? So if you make your new coordinate 3, 8, I want y'all to draw it on here. You're just going to have to run over, go 1 over 3, and then you have to put 8, 3, 8 up here. You understand? So this is 3, 8. So it says, is the new point 3 units lower than K? No, it's way high up in the air. Is the new point 3 units higher than this one? Yeah. Totally. Is the new point left? No. Is it right? No. All right. We are going to end this recording and dance.